try it again. Okay.
Turn it off and turn it back on again.
Turn it off, turn it back. Have you tried turning it off and turning it back? Oh, I think it's working now. It says excellent connection. I don't know what that means.
Have you not got a button on yours that you can just like stop streaming on YouTube and then start streaming on YouTube?
I do, but I have to keep mashing it a couple times. It sucks.
I think I mentioned this because I've got that too, but then you still have to go into. I still have to go into YouTube and like set stuff up.
Oh really?
Set it to public. Set it to public and everything.
Oh no, mine defaults. I think I have mine default. You can set what your default stream is on. Do you see how I have this? Do you see how it says like?
Yeah, that screen there.
Yeah, this stuff right here. Yeah, this defaults is what it does.
I can't get mine to do that. I don't know why.
Really? Yeah, you just go to. I think you got to go to like settings or something, like under live stream, and you can set what the default is.
I'll have not pressed A button. And...
Well, I can't exit the stream because it's gonna get mad at me.
Yeah.
But whatever. I'll show it to you later if you want. It's pretty easy. Okay. All right, let's see. Is Recky Rack up in his house? We can do his stat question. This is what we're gonna be doing.
Hurry up, boy.
Hurry up, dude. We're gonna put the waiting music on, dude. Or I can't do that one. That one gets me hit with the copyright.
What are you doing?
There we go. This one.
What are you doing?
Oh no.
Oh no. I think that's under my no videos.
What are you doing?
This is the Jeopardy music.
What are you doing?
It's very hard to make that noise that the other gorilla makes.
Oh no.
The way he screams at him. It's like...
Okay, let's see if Ace is.
I want to know how people do that.
How people do what?
Well, because the orangutan like screams at him.
Oh. No. That one.
And then the other, because the chimpanzee says no, and then the orangutan goes like sort of, and it's like, how the fuck does a human being make that noise?
Have you seen the ones where like, what's his name? The guy that does Gollum.
Oh, Andy Serkis.
Yeah, Andy Serkis. He makes some very unique noises at times. Let's see if Ace is around. Hypnotizing, more like hypotenusing. Yeah, that's true too. Okay. Or we got 1K. I'm gonna just start tagging people to see who's here. I understand our Wednesday stream is actually later than some of the kids are like going to bed at this point. Adarsh, you wanna do your question next? You're the next available person, I think. Also, if anyone who found us on Twitch, if you have a math or science question, you can go join our Discord and submit questions there. We have a whole thing. We have a whole Discord. There you go. Oh, the sensation bot isn't on this time. But yeah, here's all the screenshots. Students submit questions on our Help Screenshots channel, and we go through them on the stream live here for free. It's super dope. Darsh, or maybe is 1K in the chat? No, 1K's not there.
I don't know. We could always do chemistry.
You have a chemistry question? I'll do chemistry. I love chemistry. You want to learn some chemistry? I'll teach you some chemistry.
I've got books galore behind me.
You know what? I was actually doing some chemistry with. This is actually here. We'll do some extra chemistry just because whatever. This is me actually helping a student earlier. One sec. I gotta log in again on this. Give me a second. Where'd everyone go? It's okay. They leave sometimes.
Creators.
These are good questions. I always love these.
Proof by deduction.
Here we go. No, not that. Shantrix is asking you what you think about Napoleon. Let's do a fun one. I want to do this one. This one's fun. Okay. Or I'm gonna do this one. This one looks really fun. Okay. So they're asking us to figure out what is the heat of the reaction from the bond energies. Ooh, scary. So here we have a reaction. Yay, more math. I mean, this is kind of math. It's actually really chem famished, but so we have CH4, which I believe is methane, plus chloride gas. This will kill you. Plus fluorine gas. I think which will also... Aren't these chemical weapons that they've used in like World War I and stuff? Like chlorine gas for sure. What about fluorine?
Chlorine gas. Mustard gas.
Yeah, mustard gas. Yeah.
Fluorine gas is, what's it, colorless and odorless.
Yeah. Yeah, so these are banned. You're not allowed to do this anymore.
Probably didn't stop us, but never mind.
Yeah. So anyways, these things are all... Yeah. Geneva Convention says no. No. These things combine to then form what looks like... I actually don't know what that compound's called. CF2Cl2, something chloride. Carbon... is this chloroform? Sorry, wait, what? CF2Cl2.
Does this rag smell like chloroform to you?
Does this rag smell like chloroform to you? Oh, difluoromethane. Yeah, okay. Yeah, Geneva suggestions. Then this is hydrofluoric acid in gas form. And then this is hydrochloric acid in gas form. Wow. Yes. So Riley has a good thing. Yes, it's delta H, which is called the enthalpy change. Enthalpy is a fancy word for like heat. Although I think some people would get mad at me because they'd say, well, technically that's Q, Dr. Gold, but delta H is enthalpy is the same thing as heat. Is the sum of the bonds forming minus the bonds breaking. Yes. I do believe you're correct there. Yeah, if it takes more energy to form the bonds than it does to break them, then delta H would be positive. Oh, you finally need help? Oh, Famish will help you in a bit. Let me do this one real quick. Let's see. Bonds broken. Is it bonds broken minus bonds formed? Sorry, which one is it? Oh, it's actually backwards. We have it backwards, Riley. It's this. Yeah, you're okay. So usually it's products minus reactants. In chemistry, in general, things are usually products minus reactants. But this is enthalpy from bond energy is the one that like breaks that rule. Where it's reversed. So it's actually bonds broken minus bonds formed. And the bonds that are broken, that's usually on the reactant side, where the bonds formed is on the product side. Yeah. So when you're doing these, you have to kind of draw out what the structures are for stuff. Yeah, thermodynamics has me cooked. Yeah, the thermo. Yeah, so this is thermo. And actually, I have some other thermo questions, Riley. If you want me to go through them, I'll do them for sure. And yeah, Darsh, we'll get to yours. You have to draw out what the structures are. So luckily, we know that CH4. And this is why Lewis structures and this it doesn't leave you. You have to keep remembering it. So CH4 is going to look like this. Cl2, I believe, just looks like this. The reason being, this has 7 valence electrons. This has 7. Add those together, you get 14. Divide by 2 means you get 7 bars you get to play with, is what I say. So you use 1 bar to connect them, and then 1, 2, 3, 4, 5, 6, 7. And then these are technically lone pairs, is what they are. I have a whole video on doing these. Lewis structures are really fun. Oh, you had a science test about electrons in atomic theory. That's cool. Did you have to do Lewis structures, Santrix? Anyways. And then F2. F is the same situation. F, I believe, is 7 valence electrons. So that's also going to look like this. Okay. Then these things react. I'm going to put it on a lower line here. To form CF2Cl2. So this is a weird one. Because usually when you're writing things in chemistry, it's usually just 2 different things. Or, so you always know the first thing goes in the middle. And everything else goes around. Unless, I'm trying to think of one where it's not like this. Chemistry, like, loves exceptions, unfortunately. So there's no hard and fast steady rules for chem. But in this case, F and Cl are both on the right side of the periodic table. And C is on the left. Leftish. It's more left than these. So this means that C has 4 valence electrons that it's more likely to give. And then Cl with 7... like 1, 2, 3, 4, 5, 6, 7, is more likely to accept that so that they bond together like this. Cool, famished. I'll do it right after this. Yeah, thanks for waiting. So, and CL is the same thing, and it also has 7. F has 7, so it's really this: CCl, CCl, CF, CF, and then you have plus HF. That's just going to be a single bond like this, and then they say plus 2 HCl. Again, that's just going to be this. Yes, if it has 3 or less valence electrons and it loses them, and if it has 4 more, it gains. Usually. Unless we have expanded octets. So nitrogen's the exception to this. Nitrogen has 5, I think. But nitrogen ends up not like it does end up losing them, I think. Yeah. The expanded octets are a mess. But to solve this, right, you just take the sum of the bonds broken. So all of these bonds get broken. This breaks, this breaks, this breaks. And so that's 4 CH bonds. So you say, okay, 4 times 413. It's a single CL-CL bond. That's 478. And then plus a single FF bond, which is 154. Okay. That's all the bonds broken. However, you have to also look at what the coefficients are in front of things. There's technically 2 CL2s. So when I wrote this 478 here, I have to put an additional 2 in front of it because there's 2 sets of those that get broken. And it's the same thing with the F2. F2 has a 2 in front of it, so we have 2 of these as well. I'm not talking about the 2 on the subscript. I'm talking about the 2 as the coefficient. Cool. That's bonds broken. Bonds formed, we're going to have 2 CCLs. So 2 times 339. 2 CFs. So that's plus 2 times 458. And then an HF, but then there's 2 of them because there's a 2 in front of that. So it's plus 2 times 565. And then plus 2 of the HCLs. And HCl is 427. So let me say plus 2 times 427. Ugh, okay. Last step, I'm not going to do it just to save time, is you plug this into a calculator, you get a number, and you subtract it from all of this together to get a number, and that'll get you delta H. And then there's some cool things about delta H. So if delta H is positive, that means it's an endothermic reaction, which means it takes heat in order to happen. Or you could think of this as it'll like cool down the room because the reaction will absorb heat from the surroundings. If delta H is negative, then it is exothermic, which means that it is going to give heat away from the reaction. So exothermic reactions are good for like heating up a room. Anyways, yeah, there's a lot of cool stuff. Okay. All right, let's see. Let me help out Famished, and then yes, Adarsh and Reki, I'll get to you guys. Reki's back. Okay. What's up, Famished? Do you need help with this one? How are you allowed to solve this, Famished? Am I allowed to use a calculator? Do you want me to use matrices? There's a lot of ways we can do this one, actually. Oh, my voice cracked. Or is Famished in the... Or is not? Okay. Are you allowed to use Google? Yeah, or Chegg. Okay. Yeah, how would I solve this? I can use anything? Oh, that's scary. It seems pretty easy. Yeah, Riley, right? Yeah, so I would write this as a matrix. So what I'm going to do is I'm going to look at what all the coefficients are. If there's nothing in front of it, it's the same thing as a 1. And I'm just going to write this in matrix form. So this is 1, 2, 1, 1. This is 3, minus 1, 2, 3. The matrix, yeah, right. 2, 3, minus 1, minus 8. If I was allowed to use anything, so if I'm allowed to use what my Algebra 2 teacher would call the big gun, if I'm allowed to use a calculator, he wants a dashed line. Okay, fine. Yes, just for you. Just for you, Jeff. I'll do it. There you go. He wants this. Yeah, oh no, a calculator. Scatter. No. You could plug this into your calculator and do RREF, which will do all the math for you. It's cheating, I think. But it's how you can do it in the real world. The other way to do this is to manually put this in reduced row echelon form. So famished, what I want to try to do is try to get this to be 1, 1, 1, and then 0, 0, 0, 0, 0, 0 everywhere else. And then keep track of this. And I forget what the name for this method is. I did it yesterday on the stream, but you want to start here and you want to like do a snake. So you want to go down, fix those, then you want to come up, fix these, and then you want to come down again and fix those. It's just a convention that seems to make more sense. Okay. Let me see if I can speed run getting this, and then I'll just show you what the calculator would do. So this already starts off great with there being a 1 here. Oh, it's called the Snakes and Ladders theorem? Is that real? That's a video game. What? Oh, Gauss-Jordan. Gauss-Jordan elimination? I think it's called Gauss-Jordan. Yeah. So this is already a 1, so we're good. I want to make this a 0. Easiest way to make that a 0 is to take -3 times this row and add it to this row. Okay? So thanks to the beauty of copy and pasting things, I can just do that this way. So if I take 3 times the first row, -3 times the first row, so this becomes -3 plus 3, that's going to get me 0. -3 times 2 is -6. -6 minus 1 is -7. -3 times 1 is -3. -3 plus 2 is -1. And then this is -3 plus 13. This is 10. Cool? Then in order to get this, so we got this. We got this. Now we got to work on this one and make this one 0. The way to do that would be to do -2 of this row and put it into here. Yeah, my man, dude. Yeah.
My man.
Penn Center loves linear algebra, dude. Shout out to Penn Center. We love Penn Center. He's a great guy. Penn Center is doing a linear algebra course, I believe, with I think if I do this, yeah, courses. There we go. So yeah, Penn Center and Zach, either 2iPi, are doing a linear algebra course Monday and Wednesday at 11 o'clock a.m. Pacific.
No. Here's what Penn needs to do more of.
What does he need to do more of? Be nice. Oh, whoa. Penn Center. Sensation says you need to play more Legend of Zelda.
More Zelda.
More Zelda.
See, look, even with this horrible fucking control pad.
Dude, I love that
To be
control.
honest, I liked these actually.
I have a gold one. Penn Center says more giant lonk.
More giant.
No, I don't know what that means. Famish says, okay, so this is another method for solving it. I haven't done matrices. I forgot they mentioned they were going to teach me 3 techniques. Yeah, I mean, matrices aren't very complicated. All you're doing is taking this, but representing it in a way that looks more easier to manipulate, I would say. Let me see if you could do, like, doing it without matrices. Exactly. Yeah, Riley's 100% correct. Matrix is just manipulating the equations, but only having to write. So I'm not writing X, Y, Z every time because that sucks. Yeah, I don't want to do that. It's like sucks.
No, God.
What you can try to do is see if you can isolate for one variable. This is kind of like the backfilling method is what they call it. I don't see anything easy though. Maybe no. It would be nice if I could just cancel out one, but I don't think I can. Yeah, no. What's the other way they teach you how to do it? I'm curious, Famished. Because I could maybe see adding this equation to this equation. So that would get you 3x plus 5y is equal to -7. If I do this one plus this one. And then I need to have another equation that just has the substitution method and the elimination method. Yeah, exactly. So if I do, let's call this 1, 2, 3. If I do 1 plus 3, right, that gets me this. So then I need another way to just get x and y. And the way to do that would be 2 times equation 3 plus equation 2. So if I do 2 times this, plus, because that'll get me 2z here, which will cancel this out. That's 4x plus 3x, so that's 7x. That's 6y minus y, which is 5y. And then minus 2z plus 2z, that's gone. So then this is minus 16 plus 13, which is minus 3. Okay, cool. Now that you have this is easy, right? This is a very easy systems equation to solve because I can just subtract these two from each other. The key thing when doing this, Famished, is that when you create your equations, you need to use all 3 of them, but in different ways. If you used 1 and 3 and then used another one with 1 and 3, you're technically not getting any new information because you're just those are what we call linearly dependent equations on each other. Like one's just like a multiple of the other one. It doesn't give you any more information. You have to spread out and use all 3 of them. So if I did this, I'm going to get minus 4x, or actually, sorry, I wanted to subtract these. Yeah, so minus 4x is equal to, yeah, it's not. Yeah, well, they made this one easy for us, which was nice. So -7 plus 3 is -4. Cool. You get x is equal to 1. Okay. And once you have x is equal to 1, right, then you figure out that y is equal to -2. Exactly. Well, okay. So, yeah, what you have to do here, Famished, is you have to use unique pairs. So you have to use 1 and 3, and then 2 and 3. And I'm talking about equation 1, equation 2, equation 3. If you keep trying to use like 1 and 3 and 1 and 3, it's not going to do anything. Well, I mean, this is easy, right? So once you get this, once you get x is equal to 1, then you just plug this back in. Subtract 3, cool. Y equals -2. Now you have all 3, because now you're just doing here, right? 1 minus 4 plus z equals 1. So that's z is equal to 4, right? Is that the final answer for these? This was super nice. Yeah, that's right, right. Yeah. That's the trick. I mean, again, I was looking at you pick one variable to get rid of. And luckily, you could have done a couple of these. I could have gotten rid of x. Like x would have been very easy to get rid of too, because everything is nice multiples of each other. Like you have, if you want to get rid of x, you can use this. If you want to get rid of y, you can use this. If you want to get rid of z, you can use this. Systems of equations won't always be this nice. And so that's why they teach you the Gauss-Jordan way of doing it here with matrices. This would take a lot more time to do. We could. The process is the same. You just keep going 1, 0, 0, and then 0, 1, 0, blah, 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 blah. If you want to do this on your calculator, because here, I can show you the quick way to get the answer without having to really do anything. You just go to second matrix here. You go to edit. You make this augmented matrix. Augmented means that the answers to your system of equation are in this fourth column. The 3 by 3 here, this is the meat and potatoes of the actual thing you're trying to solve. So this would be a 4, no, sorry, it's a 3 by 4. I always get that wrong. Row by column, 3 by 4. And you just put the numbers in. So like 1, 2, 1, 1, 3, minus 1, 2, 13, and then 2, 3, -1, -8, okay? And then you go to matrix. Well, here we got to quit out of this first. Then you go matrix, math, RREF. Second matrix, the matrix you want to reduced row echelon form. Sorry, which is matrix A. Hit enter, and then there are your answers. So this will do this long process for you to get you 1 0 1 0 0 1 0 1 0 negative 2 0 0 1 4. Yeah, that is dope, right?
That's dope.
Yeah. And how you read this is, remember when we created this matrix from this, right? This row in itself, right, was the same thing as 1x plus 2y plus 1z equals 1. Remember, this was the coefficient in front of x, this was the coefficient in front of y, this was the coefficient in front of z, equals this. So when you go back and read this, right, this is the same thing as 1x plus 0y plus 0z equals 1. And, right, 0y, 0z, I don't care about that. That goes away. So this just tells you x is equal to 1. And by the same token, right here, this is 0x. Oop, we went over a little too far. This is the same thing as 0x plus 1y plus 0z equals negative 2. So y equals negative 2. And then this is z equals 4. Yeah. But yeah, the calculator will do it for you if you want. The reason why you probably didn't get this working, I'm guessing what you did is maybe, well, I'm actually curious what you did. You said you couldn't get anything to, I spent hours trying to find that, like, no matter what I did the elimination, it never gave an answer. Yeah, so what you did is you probably, like, just added these two together, right? You have to add one as a, what's up, Seth? You have to add one as a multiple of the other. So in this case, you could have, yeah, you can't just add this to this. You have to add multiple. You have to eliminate a variable. If I wanted to eliminate y, for instance, I would use these two, but I would multiply this one by 2. Because then what you would get is you'd get x plus 2y plus z equals 1. This would be 6x minus 2y plus 4z equals 26. Now if you add these down, you get 7x, these cancel, plus 5z equals 27, okay? And then you need to find another equation that just has x and z. I agree, z is the easiest to eliminate. Yeah, and that's what we did. I believe we did it somewhere. Did we do it here? Yeah, we did it here. Yeah, the first way I did it was I just did 1 and 3 just to eliminate the z's. And then we did some combination of 2 and 3 to eliminate that z as well. I agree. But this would be the way to eliminate y if you wanted to. And then you have to use another set of equations to eliminate the other y, which means you have to use this third equation that you didn't use the first time with some combination of these to get a new equation. Yeah, it's okay. Yeah, if you... Yeah, eliminate one variable and then just use the other equation to eliminate the same variable again. That's what you got to do. Because then if you tried to use this to eliminate, I don't know, z, then that wouldn't work because this has z in it. And this only works, by the way, this substitution method only really works when you have only 3 variables to solve for. Otherwise, this becomes really messy because let's say you have 4 variables to solve for, then you're condensing... Unless you get lucky, you're going to condense 4 variables down to 3, and then you have to do this again to condense it down to 2. Yeah. Yeah, solve the system. That's what I was asking, Seth. I was asking Famished at first, like, how do I get to solve this? You know, can I use the calculator with RREF? Do they want Gauss-Jordan? And then he said that they were using substitution and elimination, so we just did this way. Yeah. Right, yeah, I used a matrix, but then it turned out, and this doesn't happen often, that you could just do elimination because it was really easy to eliminate one of the variables with just like simple multipliers. Yeah. You like substitute eliminate? Oh, interesting. So wait, you isolate for a variable and then you plug it into here. That for me gets like really messy. Really messy. Yeah, I don't like... I like to just eliminate and then substitute. Yeah, otherwise I forget like how to distribute things.
So careful, you nearly turned into a valley girl then.
A valley girl, yeah.
You nearly turned into a valley girl.
What's a valley girl? Tell me. You mean like the valley girls from like LA? I know what valley girls here are.
Yeah.
Wait, is that a thing? You
Oh
know
my
about
God.
valley girls all the way from the UK, dog?
Got some messy.
God damn it. But good. Yeah, good job, fam. Great question. I appreciate that one. That's cool. Okay. Valley girls, dude. I haven't heard that term in forever, dude. Valley girls.
I don't even know if it's still a thing. It was just a thing for a long time.
Yeah. Let me see if I can like put up. Okay, Reki, we'll do yours. You're next. You're up here. You're here. Yeah. What's it? Let me just get an image for Valley girls real quick. I got to.
Earth Girls are easy. Greatest movie ever.
Oh, there was a movie called Valley Girl from the 80s. Girls do not dress up like this anymore. What is this, like the next Barbie film? There's way too much pink going on.
The good old 80s.
Good old 80s. Neon, and it's like it's neon pink and neon blue.
And really big
Like-
cell phones.
Like this, just this color scheme. Neon pink and neon blue. I like it. It's aesthetically pleasing.
See, that's not quite right. That's Neo. Well, no, Neo New Wave.
Neo New Wave. Okay, yeah. To me,
Like
it's like very
cyberpunk.
Miami. Yeah. Fam says we know Gold is gonna watch that tonight. I don't know. I actually generally detest the 80s. I'm sorry for those that are offended. It's just like this awkward period in time where they were starting to get technology, but it wasn't good enough. So the CGI and stuff looks like really bad to me. Someone's gonna yell at me for
See,
that, but
to me, the digital age didn't even start until 1999.
I agree. I would say that 90s films are like only slightly better, but also suffer from the same problem of the tech is almost there, but it's noticeably bad. 1 MIPS, we can send 6 messages. Yeah, dude, the tubes, dude. You know what a T1 line used to be? T1 was like woo, was the big thing in the early thousands. You can only really get it with a business account, but it was 1 MIP up and 1 MIP down. That's what a T1 line was. It was seen as like super fast internet. Now you can get gigabit line. You can get thousands, or multi-gigabit at this point. 1.544 MIPS. Is that really what it is? Let's see. Thank you, Sensation, for handling the YouTube chat. Okay, Reki, let's do your question here. A manufacturer of smartphones has created a new phone model. The mean life of this phone is 48 months. Wow, that's a while. I don't think that really applies these days. Didn't Apple get in trouble for doing this like planned obsolescence thing, where the battery intentionally just starts breaking after a year or two? Yeah. Android lasts like 6 years. This is a statistics question, correct? The manufacturer has offered a 24-month warranty of the model. Determine the percent of phones that are expected to malfunction during the warranty period. Ooh, okay. Okay. So let's kind of like draw our distribution. This will maybe help us. So it has a mean life. We're going to call it X bar. Or let's call it mu, because it's technically the population, of 48 months. And a standard deviation of 12. Okay. So if we draw a little normal distro, the best bell curve I can draw, I guess, at this point. That's 12 months. So 1 sigma, 1 standard deviation away, would be 36. And then 1 sigma above Where's my dash line? I can just copy this. Would be 60 months. Yeah, nice graph. It's a nice graph. Z-scores. Yeah, exactly. Okay, cool. Yeah, Reki, so how do we do this? So the warranty period, they say, is 24 months. Okay? So they're saying we will cover these phones up to 24 months, which is like this. How do we figure out the percentage of phones that are expected to break during this time period? Yeah, technically, yeah, we just want the percentage of phones. If we wanted the number of phones, you're right. I need a sample size. I need an N. I need a bunch of stuff. There's a way to do this with math and, well, I mean, we have to use math for everything, but there's a way to do this with a calculator and a way you don't have to do this with a calculator. Yeah. Yeah. You could use calculus if you wanted to write out the Gaussian distribution, which I think is like e to the something. I want to say it's like e to the minus something something. No calculus is needed. Yeah, okay. But how do you do this, Reki? How do you figure out? How do you figure out the percentage of people, a percentage of phones that would expire during the... Oh, it is e to the minus x squared. E to the 2i pi. I know him. Endar, exactly. Endar brings up a very good point here. He says, right, do they do this by the z-score, or do they approximate it with the 99, 95, 68 rule? Yeah. Yeah, there's two different ways to do this. Yeah, all the gangs here. Yeah. How would you do this one, Adarsh? We just use z-score. Okay. So how would I figure out the z-score? We'll show both ways, because they picked some very interesting numbers that make it easy to do this without a calculator, actually. Yeah. So z-score, yeah, is equal to what? How would I calculate the z-score, Darsh? What would the z-score be? And then we'll probably... Oh, Reki. Sorry. Yeah, Reki. Yeah, sorry. Reki's Ayush. My bad. Wait, does Reki and Adarsh, do they know each other? Do they go to the same school? Okay, they do know each other. Okay. Alright, that's why I get them confused. Oh, they don't. Oh, Shantrix knows Reki. Adarsh does not. Oh, okay, that's cool. Okay. Yes, so we do x minus mu over sigma. I think I know my brother. Oh, Shantrix is like, that's my brother. Okay, cool. Okay, cool. So that's going to be 24 minus 36 over sigma, right? Or is it? Yeah, it's not 24 minus 36. What is it actually? What's the number? I made a mistake here. On purpose. Statistics is very cool. I like statistics. Good. X is the number we're looking at. I agree, Riley. Good. Mu is 48. Good job, Reki. Yes. Okay. 48. Okay, good. This gets us a z-score, which is going to be negative 24 over 12, which is equal to negative 2. The reason why this is special is anytime your z-score is a whole number of standard deviations, like one standard deviation, 2, 3, that's also what z-score represents. I think a lot of students just get slapped with the equation of what a z-score is. And I don't understand what it's representing. Z-score is representing how many standard deviations you are away from the mean. So if I want to look at the z-score for 60, I know 60 is one standard deviation away from this. And look at this. 60 minus 48 over 12 is 12 over 12, which is just equal to 1. Yeah. That's all it's doing. When you do x minus mu over sigma, it's saying how many sigmas is this difference. And so if this difference is equal to 1 sigma, then you're going to get a z-score of 1. That's all z-score measures. It just measures how many standard deviations you are. Yeah. It's pretty cool. So we could do this using a z table, which I've brought up before. I'll pull it up. One sec. Okay, here. This is what I want. Copy image. Nope. There is a way. Yeah, there is a way to do it without a calculator. I'll show all of them. It's pretty cool. So this is called a z-score table, and what this is this is a series of pre-calculated numbers that will say what the area is in a Gaussian distribution in a bell curve like this for a certain value of z. So z was equal to -2. Let's remember. So if I look here, -2 is just going to be this number. How you read this table is this leftmost thing, like how far down you go, row-wise, that's to the 1 decimal place. And then how far you go over column-wise is to the 2 decimal place. So if you wanted to know the z-score, for instance, for -1.96, which is an important one, it comes up all the time, you would move this down until you get to -1.9, right? We see that? -1.9. And then to get the 0.6 part, or the 0.06, you would move this over until you get to 0.06. And then this right here, this intersection, that is the number that the area is represented. Good, the first quartile. Yeah, so this is cool. Yeah, -1.96 is a very important number. Do you see how the area here is exactly 0.025? That comes up a lot in statistics, because if you have 0.025, which is, let's say you have 2.5% here, and then let's say you have 2.5% here, that means you have a total of 5% in the tails. This is 95%. And this is what's represented by a 95% like confidence interval or confidence level and stuff. Is z-score for proportions only, or can it do means as well? No, so z-score can be for anything as long as you know the mean. If you know the mean of a population and it's a number, I think you're thinking of. Is it a t-score? I don't think it's a t-score, but it's, one sec, z-score for proportions. Yeah. If you have something where it's like percentage of drivers or percentage of things, this is the other, you can also use a z-score, but this is more for like samples. Yeah. Yep, and then you can do this weird thing where if you're testing 2 proportions against each other, you have to decide whether you pool the variances or not. So, this gets even harder. Yeah, statistics can get like really weird. But anyways, here, I'm gonna pull this. We want this picture in later. Anyways, yeah. So, but for Recky's question, we just did -2.0, so that's just gonna be this. So that's gonna be 0.0228. Okay. So I can say that this is 2.28% is that. How far does this table go? I mean, in this case, this one will go to z-scores of up to basically -3.5, where the area is, this is such a small area. It's like almost 0. If you want to do this on your calculator, good. Why only negatives? Because you only need the negatives, Seth, because if I want to figure out the area that is above here with positive z-scores, it's symmetric. So, for instance, if this z-score is -2, and that represents 2.28%, of the population that's, I don't know, below there, this being positive 2 would also represent 2.28% that is greater than that number. So if you ever have to figure out the area to the right of a positive Z number, you can just look at what the negative one is. If you wanted to figure out the proportion of phones that's over here, the cool thing we know is that the total area here is 100%. So whatever area you get here, if you want to know the probability of it being above that, you just do 100% minus whatever this area is. It is what it is. Yeah, but sometimes they'll give you tables. Dude, Z-score tables are wacky, dude. I've seen some tables. Yeah, so they usually do the area to the left, but then this will do, for instance, positive Z-scores, but it's to the area to the left of positive ones. Or man, they'll do this. Like this is, dude, this is really weird. You have to look at the picture here. So this gives you the area for a positive Z number from the midpoint to that number. And then again, because Seth, this is symmetric, it's the same area. It's 50% is on the left of this middle number. Oh my god, yeah, Shantrix, I've seen that before. Yeah, the peer review system's kind of broken. That's a beautiful example. I've seen that one before. Yeah, so you have to read the table and see what they're telling you. This is another one. So this one always gives the area to the left of the Z number, and they'll do it for the negative and for the positives. But in reality, if you wanted to figure things out, you can always just know it's symmetric and then do 100 minus that number if you need to. Yeah. Anyways, so yeah, we got 2.28%. The other way to do that would be, you can pull out your calculator here, and you can go to you can just go to stat, and then go to, where is it? Someone showed me it last time. Oh, sorry, no, second distribution. Okay, and then if you do normal CDF, this will take the area and something all the way from, we're gonna say like negative infinity, right? You can't have negative time, but whatever. Yeah, that's negative infinity is basically saying give me all the area from here onwards, and you can put in the numbers here. So I could put in the, if I just want to put in the Z number, I could just put in -2 here, and you leave that as a mean of 0 with a standard deviation of 1, because that's what a Z distribution is. A Z distribution has a mean at 0, right? It's centered at 0, and it has a standard deviation of 1. And this will give you the same number. You see, we get like 2.275, 2.28. It's the same number. If you didn't want to calculate the Z score because you're just super lazy, you can do normal CDF, and you could literally put in the number. So in this case, I could put in 24. I could say that the mean is 48 and the standard deviation is 12, and it'll do it as well. It'll get you the same number. If you just leave it as mean of 0 and standard deviation of 1, you got to put the Z score in. If you don't want to calculate the Z score, you can put in the mean and standard deviation as well. So yeah, those are cool ways. So okay. Then they say what percentage of phones are expected to malfunction during the 2nd and 3rd year of use, right? So that's the amount of phones that break here, and also break in the 3rd year, which is here. During the 2nd year? Is that after 24 months? Or is that between 12 months and 24 months? So what's the calculus side of it? The calculus side of it would be to do what I think Jeff said. You could write this as a distribution. This is, I believe, like e to the minus x squared, and then there's some like mu minus something over sigma. Exactly. Yeah, you just integrate over the bounds. You can also, if you want, This is the rule that people were talking about. This is the important rule. Where these represent standard deviations. So this is 1 standard deviation. This is 2 standard deviations away. Or here we can say -1, -2, -3. And it's called the 68, 95, 99 rule. And what it means is that if you are plus or minus 1 standard deviation from the mean, you occupy an area of 68. You said it earlier? Cool. Nice. Yeah, good job. Good job. Good job, Reki. Right. Yeah, those are the numbers. This is the main one they memorize. And then you know to divide 68 by 2, so that gets you 34. Then 95% of the data is between 2 standard deviations, and 99% of the data is within 3. Oh, sorry, I should put the -3 here. Yes, you did. So, if I wanted to figure out, again, the stuff that's below 2 standard deviations, it's this amount, which is the same thing as 50% minus this amount. So, from here onwards down, that's 50%. And then if I subtract this amount, so that's 50 minus 13.5 plus 34, so minus 46, 47.5%. That also gets me like my 2.5%. Which we can see is not exact, right? It's not the 2.28 I wanted, but it's close enough. Is it 99.7? Is that what it is, really? 68.95. Oh, maybe it is not. Oh, you're right, because the 0.15 is a 0.3. Yeah, you're right. Yeah, sorry. Yeah, okay. Yeah, nice. Expected to break during the 2nd and 3rd year of use. I would say this and this. So I think they just want this area, which is just the whole 50% minus the 2.28%. Seth's going to say, no, it's from 12 to 24. No. Okay. Yeah, all right. If we wanted, yeah, so he is, okay. Yeah. If we wanted from 12 to 24, I agree. The 2nd year of use. Okay. So let's remember this was 4 years. This was 3. Okay, let me just do this. 4 years, 3 years, 2 years, 1 year. So they want this to this and this to this, right? Between the 1st and the 2nd year. You could just say it's this amount is what it is. Which the other way to do that is you would have to find a z-score for -1. Okay, you'd have to find that. And then you'd have to subtract it from the area from the z-score for -2, I think. No. Yeah, wait. Yes. Sorry, -3 and -2. Yeah, sorry, that's what I meant. Yeah, sorry. Well, okay. Between the 1st year would be -2 to -3, right? Oh, it's only a 1 year period. Wait, they say during the 2nd year and the 3rd year of use. The 2nd year of use, humans start counting at 1. Oh, you're so right. Sorry, the 1st year of use is 0. Oh my god, that's messing me up so much.
Surprise, motherfucker.
God damn it. Yeah. During the 2nd and 3rd year of use? Right, so wait, the 1st year of use is from 0 to 12. So the 2nd year of use is from 12 to 24. And then the 3rd year of use is from... That's messing with my head there. Sorry, what? That's between 24 and 36, right? Okay. So, yeah, you'd have to do the z-score for 36, get an area. And then you'd have to subtract it from the z-score from 12. And that'll get you an area. Yeah. And then subtract the 2 areas. I think you can actually do this literally in Can you do Z interval? Or I don't think so. But here, you could do this. So we could do here the Z score, the Z area for Z36, which is that, and then we can subtract it from the area for 12. Oh, okay. And that just gets you, 0.157. So 15.7%. Cool. Oh, you were so right, actually. Yeah, and thank you, Endar, for showing that to me. Yeah, so sorry. You can choose the lower here. Yeah, we could just do this. We could just say 12 to 36. Oh, yeah. That'll do it as well. Thank you. Same thing. You're right. It does let you enter at a lower limit. I just say on a statistics test and whatnot, they want you to know the concept of, for instance, if I want the area between like here and here, that it's this Z area minus this Z area to get you this area. That it's one of the big things they try to test you on to mess you up. It is what it is. Okay, good. All right. Good job, Reki.
Speaking of nice, has anyone actually seen him recently?
Last I talked to him, did he finally block that girl that was just wasting his time? I forgot.
I think she lives within like an eighth of a mile of him.
He needs to get out of his town, dude. I tell this to a lot of people. The big advantage of going to college is to just get out of your home environment, like get out of your parents' house and stuff. Like go be an adult and figure out life, because otherwise you get stuck in these loops. All right, good to see you, Chantrix. Appreciate you being here. Okay.
Well, what was that thing from World War Z?
World War Z.
Trying to explain to the guy in Spanish. You know, life that moves stays alive.
Oh, a body in motion stays in motion. That's like a physics concept.
I just mean, if people migrate, they tend to stay alive.
Yeah. There's the funny one in academia. It's called publish or perish. So as a PhD student or as a professor, you have to keep publishing papers, because if you don't publish papers, then you perish. Yeah. Which
That's
actually it leads to problems though, and this is something that Chantrix was bringing up, is that then people just start publishing whatever they can, and there's so much like noise and garbage in academia because an insane amount of papers are coming out, such as this one where some med student feels like they published something in diabetes care, like some weird ass journal in 1994 that basically proved calculus again. It proved like they're like, I'm gonna come up with this new math, and it's literally fucking Riemann sums. It's hilarious.
I don't know whether this is still a thing, but when I was growing up, in order to maintain a Bachelor of Sciences, you had to publish a white paper every year.
Oh, okay. Every year?
Every year.
Wow, that's a lot.
If you didn't, your BSc became void.
Oh, wow. Oh, that's interesting.
Don't know if that's still a thing. Probably not, because I mean, you can see some of the absolute fucking thickos in our universities now. It is absolutely mental. Since they basically said, "Oh yeah, you can go to university if you pay for it," people just started paying for it.
Yeah, it becomes like, a for-profit thing.
Mate, you shouldn't have even got out of fucking secondary school. What are you doing?
Surprise, motherfucker!
Well, no,
you know
I was teaching Chinese and Japanese students English.
Okay.
Like 10 years ago, whatever. And so I'd go into these student accommodations, which was just basically sweat boxes. I can't really describe them. Just the maximum amount of people in the smallest possible space.
Sure. Just to cram people in for like tuition money.
40 floors of, Yeah. But, I mean, most of them were absolute fucking shitheads. I mean,
wow.
They wouldn't have seemed out of place living on the council estates.
Yeah, I love that I know what a council house is now. I've learned so much through this stream with you.
Just full on, just walking around in like tracksuit bottoms, tracksuit top, and a
tracksuit. Like, I need a gold tracksuit. Yeah, so there's an interesting thing. I learned about this today when I was interviewing for this UCLA position. So apparently, if you teach a class at UCLA and you need to dip out for a week for whatever reason, like you're sick or you have to go to a conference, you can have someone sub in to teach the class as long as they have a master's degree. There's no other requirement.
Of anything?
Anything. You could be a fucking murderer, or like they don't even do a background check. They just say this person just needs to have a master's degree. Just like, what?
That's strange.
Imagine there's so much security in everything and whatnot, right? But whatever this rules in place is, yeah, if a professor has to take off, they can just appoint a substitute, and as long as that substitute has a master's degree in physics, they don't care anything else. It's nuts. What?
I imagine the shit kicked off, they'd blend the person that substituted them in, though.
100%. Yeah, no. It's one of these things where you got to vouch for the person, right? If you end up getting P. Diddy to, like, teach your math class, you know, like, you're going to get into trouble once the baby oil starts coming out or something.
What was up with that?
I don't know. His house burned
Baby
down.
oil.
Dude, all the evidence burned down with the Palisades, man, I swear. Anyways.
Using baby oil, I'm not surprised.
Okay. What's up? Sorry, this is Adarsh. I need to get the names right with people. I'm sorry. Adarsh's question. Okay. Yeah. Ooh, f of x. What's up, Ski?
Oh, whilst Mr. 115 is here, I'm not going to call him out directly, but you know who I'm talking about. We need you back. He's
Mr.
looking in the chat. I don't want to call him out implicitly.
115. Who's Mr. 115? Okay.
You'd know if you clicked on his name. You'll see it in the viewers.
Wow. Oh, Mr. Danny Highway. Wow, dude. I do miss Danny, dude. Brother, you can call him out directly. Wow, Mr. 115.
I didn't.
Dude, what does the 115 mean, dude? What's the significance of that?
Well, it's just in there somewhere, so I've kind of tried to call him out without calling him out.
We see you, Danny. I miss you, Danny.
So, yeah, it was like, seriously, we need you back.
Yeah, we do need you back, dude. I need you back. I know you have your grievances with like streaming right now. Or you're I call this you gotta like refocus sometimes. I do this too, actually. During the winter break, I just stop streaming for like 3 weeks because I just need to clear my head and figure out what are we doing here, because otherwise it just becomes this kind of like you just go on. Yeah. All right.
There's too many shitheads on Twitch. We need less shitheads. I want more good people.
We need more positive discourse. And Danny, you were a beacon of light for that. I appreciated all your discussions. They were really fun. And they could still be fun.
I understood fuck all of it, but it was still fascinating to watch.
No, he had some good like political debates too, and like philosophical things. I really liked them. Yeah, they're super fun. Yeah, you're still mentioned, Danny, sometimes when we'll get into like some heated debate of something, and someone will be like, "Oh, where's Danny? I need Danny's opinion on this." It would just be hilarious, dude. Especially with what's going on in the world these days, man. Holy shit, Danny, you'd have so much material to work with. Anyways, okay, here I got 10 minutes. I gotta go teach a kid AP chemistry after this. So, all right. Let's see. Still debating, just not on Twitch. Ooh, where do you debate? Tell us, Danny. Where can we find you? Or are you just talking about in general? He's probably doing it IRL though. Yeah. Which, if I'm not mistaken, Danny, do you live close to me? I forget. Oh, holiday parties with family? Oh my god, yeah, those must be a riot, dude. Especially if your family is divided, you know? If you got that one crazy uncle that votes for Trump and that other crazy uncle that donates half their mortgage to Kamala Harris, that's always fun. Oh, you're East Coast. Okay. That's right. Oh, Dawn. Dawn is the one that's on the West Coast. Dawn's in California. That's right. The Dawn father. Dawn and Danny. Yeah. Are you still working for Chegg, by the way, Danny? I might cancel my subscription to them, unfortunately, this month, because now I'm realizing I don't actually ever use it anymore because I have ChatGPT. Nope. Okay, good. I hope that's a happy thing you're not working for Chegg, because their stock market, their stock value's doing fucking terrible. Chegg had major downsizing. Yeah, I imagine so. Yeah, they're shitting their pants with ChatGPT. And again, it's the reason I'm looking at it. I used to pay for Chegg I still pay for check. I'm probably going to stop after this month because it was very useful for helping me to tutor kids to find like obscure questions I didn't know how to do, and I could just teach myself really quickly. But now I can do it with ChatGPT. You're sad about it? Yeah, it was a good company. I like Chegg. Don't worry. But it's one of these things where new tech comes out and it's like adapt or die, I guess. I still have an iPod that Chegg sent me. No way. Oh, that's cool. Well, tell us what's next in life for you, Danny. I always like to know. When I inevitably stream, there'll be a sad, angry Chegg rant. Oh, I'm here for that. Dude, Danny, if you want to come onto my podcast and, like, talk, like, if you don't want to have to do the whole, like, set up another stream and whatnot, I would love to host you, man. Fridays. I know last time you're, like, busy on Fridays with work, but maybe that has changed now. If you want to. I'm sure we could get we could get a lot of fun questions out of you. Anyways, yeah, oh, TikTok. You're right, Seth. I gotta go in 7 minutes. Far future. Ain't saying no. Great. Love it. This here's all we're good. All right, domain. Anytime I see square roots, the domain needs to always make sure that we're not taking the square root of a negative number. So anytime I see this, I just take whatever is underneath the house or in the radical, and I make an inequality out of it, and I set that greater than or equal to 0. So in this case, I'm gonna say x plus 4 is greater. You're right. There is a graph to use. I could use the graph, but let's show how it works. Because sometimes you won't get the graph. Just always do this. Just take whatever's inside here, do greater than or equal to 0, and then solve. Move the 4 over, right? I get x is greater than or equal to 4. Now you're done. Cool. X greater than or equal to -4. You can see that as well, right? Starts at -4, goes that way. Cool. The range. This one's interesting. Again, you can look at the graph. You can see that the highest it'll hit here is up at -3, and it'll keep going down. If you didn't have the graph to do that, always look at, like, the parts of what's going on. This little bit here, the smallest this can ever be is 0. Because square rooting something can never get you a negative number. The smallest it can get you is 0. So I always like I like to note that. I'm like, okay, what's the smallest this thing can be? The smallest thing can be 0. The biggest it can be is infinity, and that's negative infinity. So that tells me, like, the furthest extreme it can go. So if this thing was the smallest it was, which was 0, then -3 is one of my boundary points. And then if this thing was the biggest it could be, which is infinity, then negative infinity minus 3 is just negative infinity. So that's my other boundary point. So now I just rearrange, like, which one is smaller. Negative infinity is smaller, so I'm going to put that first. And then comma the other one, which is -3. And then this one's a bracket. This one's parentheses. Because in math land, you're not allowed to include infinity as a number, but you can't include -3 in this case. Cool. All right. X-intercepts, there are none. Because this thing will never hit the x-axis. Y-intercepts, you can see where that is. That's at 0, -5. The other way to figure out the y-intercept is to plug in 0 for x and see what you get. So if I plug in 0 for x, I get negative square root of 4 minus 3. Yes, good, Seth. The range also proves the intercepts. You're totally correct. Since y equals 0 is not in the range, that means we cannot have an x-intercept. Not going to work.
Oh, no.
Also see my proof. And you see your proof. Okay. So the y, if I plug that in, square root of -4 is 2. -2 minus 3 is -5. Yes. Square root of x is equal to -3. That can't be, of course. Yeah. Increasing, decreasing. Okay. So they're saying, like, interval, I guess, of where this function is increasing. It never is. It's always decreasing. Okay, so this is none. And then it is decreasing. Well, it's always going down. So this is going to be from -4 all the way to positive infinity. Parentheses on the positive infinity. Interval of positive, none. This function will never be positive. It always goes down. Unfortunate. Interval of negative, same thing. It's always going to be negative. -4 to infinity. rates of change between 3 and negative 12. So when they want the rate of change, so ROC, you just do y2 minus y1 over x2 minus x1, where these are the points. Good. So my x points are between 12 and negative 3. So 12 minus negative 3, that's going to be 12 plus 3. It says not true. Why is it not true? Well, oh, you know what's interesting? Well, as long as the points are valid, right? Yeah, they're saying the average rate of change. Yeah. They're saying the average rate of change is called the secant line between these 2 points. So it's from here to like way over here. Right? Yeah, it just says rate of change. When they put 2 values like this, we assume that's the average rate of change. Because instantaneous rate of change would require calculus, and we'd also only have 1 point. So yeah. So then that's... So in order to get the y's, you got to plug these values in. It's kind of annoying. So if I plug in 12, I get the square root of 16, which is 4. Negative 4 minus 3, that's negative 7. And then minus... Thank you. Yeah, exactly. And then at negative 3, that's going to be negative 1 minus 3, which is minus 4. Good. Thank you, Seth. Yeah. So negative 7 plus 4 is negative 3 all over 15. So the average rate of change is negative 1 over 5. Nice. Cool. All right, great. Good question there, dude. All right. And... Oh, wait. Seth says wait. Oh, end behavior. Thank you. Pause.
Yes, he went to 7. Oh.
I have not completed. Yes, you're so right. I could do the end behavior. Okay. End behavior is talking about what happens to this function as x approaches negative infinity and x approaches positive infinity. Now, this function can't go to negative infinity for x because it stops. So I don't know what they really want to say about end behavior there to the left. But for the right, I can see that, yes, as x here goes to positive infinity, this function keeps going down, which means the y is going to go to negative infinity. So I believe the way to write this, Adarsh, is you say the limit as x approaches infinity, f of x is equal to negative infinity. And you can see that here. As x here gets really, really, really big, you have negative infinity minus 3, which is just negative infinity. Yeah. So yeah, you say as x approaches infinity, the function, which is y, approaches negative infinity. You can also write it this way. Yeah, this is probably the pre-calc way to write it. I think they probably do it this. Yeah. Using non-calculus wording, yeah. Okay, good. That's a good question. Adarsh. Nice. Okay, cool. And with that, I gotta go teach, so let's go ahead and up the stream. You're not allowed to use the limit definition and this is calculus? Yeah, you're right, yeah. Oh, they do limits in pre-calc, Seth. It's a new thing. They start doing limits in pre-calc. I've seen it. We are gonna raid. Yeah, we are gonna raid. Anyways, yeah, cool. Thank you everyone for coming to Actual Education Office Hours today. Appreciate all the questions. Thanks, Penn Center. Yeah, make sure you go check out all our awesome, fun math streamer friends. If you want more math in your life, they are there for you. There's all our friends. And then here's the calendar. And then here are the courses that are being offered. Penn Center, let me know if I need to update the time for y'all's linear algebra class. Limits are for calculus. Thanks, FanFox. Yeah, we're dude. They're starting to do limits in pre-calc. I'm telling you, man. I teach a lot of kids, and in their pre-calc classes, they're doing limits. Oh, we're switching it to 2 to 4 Eastern. Okay, I'll update that. Yeah, I see limit. Yeah, it's new. You're right. Limits used to be exclusively a calculus concept, but I think even on the AP pre-calc exam, which is like, what the fuck is AP pre-calc? But I don't know. College Board's just trying to make more money. I think limits are on the syllabus. Yeah. Wow, Penn Center's like, I found Danny. He's like, I found him. Yes. Yeah. Okay, cool. All right, let's go raid somebody. Who's still on? Who's doing stuff? Astro Canuck is doing Lego building. That's cool. Ooh, I like these guys. Let's go check out. Their name is Ask a Scientist Gaming. These are very cool. So these are two professors that they play video games, and there's always a new professor that it's kind of like what I do with Fridays for the AMA thing. You can just ask them questions. So it looks like they have someone who's in mass spec, mixture analysis, and they're playing Kirby. So let's go check them out. I usually get them like kind of late. Yeah. All right, cool. I'll check for the message. All right. Have a great rest of your week. Awesome Wednesday. We will see you guys next week for Monday stream at 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. Peace out.
Like you're taking it from
Yeah, I'm taking one for the team.
and the sound effect is